Alright, 5.3 features of functions, a practice understanding of task. So we've kind of connected in the 3 tasks so far. We've connected together graphs and stories, then using tables and graphs and features. We've started getting those, and now we're just going to kind of put it into practice. So on all of these, we're just finding mainly those key features. And those key features we're talking about is the domain, the range, so the x values, the y values, increasing, decreasing, the x-intercept, y-intercept, the maximum value, and the minimum value. That's what we're looking for here. So, question number 1. Domain. Well, we go as far left as -3 over to 4. So it would be from -3 to 4 is our domain. Our range, well, we start down here at 0, and it goes up here to 4. That would be our range, from 0 to 4 on the y-axis. Okay. Increasing, decreasing. Where are we increasing here? Well, we can look at the graph. We're increasing up as we go right there, right? And then we are decreasing from here. So the intervals would be from -3 to 1 is when we're increasing. You know, that's the section of the graph. Remember, the intervals deal with that. That's the section of the graph that we are increasing from -3 to 1. And we are decreasing from that 1 till we get to 4. That section of the graph is where we're decreasing. So it would be from 1 to 4. Notice if we put the increasing and decreasing together, that gives us our domain, because our domain is the whole part. Okay, so now we look at x and y-intercept. X, where does it cross the x-axis? Well, easy, 4, 0. Where does it cross the y-axis? Not so easy on that one, is it? It's a 0, 1, 2, 3, maybe 3.2. Close enough, right? Maximum point would be up here at that B, so 1, 4. So 1, 4 would be our maximum. Our minimum, our lowest point, is the same as our x-intercept, right? So it would be 4, 0. So there are the key features there for that first one. Okay, now let's take a look at our next one. So that's all we're doing. Just a bunch of problems where we're deciding what's going on. Okay. And, you know, I guess we could also include that this is, in our domain, this is a continuous function. You know, you may want to add that as well. But it's more than just linear or exponential, so it would be in neither category. Okay. Alright, now we look at number 2. So this one's kind of a different graph. We could also say on number 1, is it a function? Yeah, it's 1 to 1. Whereas if we look at number 2, it is continuous, but is it a function? It's not a function. Okay, those are the other aspects that we would probably want to talk about. Okay, so domain. Well, what's the furthest left we go? Well, we start here at 0. Okay, so our domain starts at 0, and then it keeps going. Notice it has the arrows here. That means it's just going to keep going to the right until we get to infinity. So our domain goes from 0 to infinity. Okay. Well, what about our range? Our range. Well, how far down are we going to go? It's going to keep going down. Same with up. So range, there's 2 ways you could write this. You could say all real numbers, or you could go from negative infinity, because when we go down, that's negative infinity, to positive infinity. Each one of those would work. Okay, increasing and decreasing. Well, it's both increasing and decreasing the same, right? It's from 0 to infinity. It's the same as the domain there. It's the same as the domain. So I just wrote it for both. Okay, do we have an x and a y-intercept? Yes, we do. Where are they? Well, it's both where it touches at the origin, right? So they're both 0, 0. Do we have a maximum or a minimum? Well, this is just going to keep going up. This is just going to keep going down. So no. We don't. It's alright if we don't have some of those features. Okay? So, let's take a look at the next one. Alright. So, once again, first idea, discrete or continuous. Well, if we're just talking from our domain, then it would be continuous. I guess if we're talking as all real numbers, it would be discrete, but we want to just focus on our domain. So our domain, the furthest left we go is right here. Furthest right is here. So from -8 to 10. That's our domain. And within that interval, it's continuous. Is it a function? Well, if we did the vertical line test, it would pass, so yeah, it's a function. Now let's take a look at our range. Okay, so the lowest we go is -3. So we start at -3, then we go up to 5. So our range, -3 to 5. Okay, what about increasing and decreasing? Well, we start right here at -8. We're going up, up, up till about probably 0. So increasing from -8 to 0. Then we start decreasing, right? From 0 down to probably about, we'll say 5.5. You could go 5 or 6, I'd accept either one. But from 0 to about 5.5, we're decreasing. Well, then it starts increasing again until we get to 10. So we do the little jump and say, well, from 5.5 then to 10, we're increasing a second time. Okay. Now, x and y intercepts. X-intercept right here, y-intercept right here. They're a little off, so it would be x-intercept is about -6.20, and y-intercept is 0 and about 4.2, we'll say. Okay, those ones shouldn't be too hard. X-intercepts and y-intercepts should be super easy. And max and mins are generally pretty easy as well. Our lowest is right here at -8, -3. So that's our min, -8, -3. And our max is up here at 10.5. 10.5. Remember, as we're talking about these, max and mins, x and y intercepts are always points, whereas domain, range, increasing, and decreasing are the interval notation. Okay? Let's keep on going. So now we've got a discrete function, right? Definitely discrete. Is it a function? Yep. Passes vertical line test. So because it's discrete, that affects our domain and our range. So instead of doing it as an interval, we're doing set notation, which you start with kind of brackets, and then we pick the x values. So we've got maybe about 0.8. Then this next point is at 2. The x value, oh crap. That's 2. So this would be 1. 3, 4, so that'd be 3.5, 2.5, 1.5, 0.5, so like 0.4. And then 1, so there's that x, then 2, then 3, and then 4. Okay, so there's our domain. Now our range. So once again, we're counting by 0.5s. So the lowest is probably 0.25, then 0.5, then 1. 0.25 because it's halfway between 0.5. 0.5, 1, 2, and 3. Okay. Now, is this ever increasing? Nope, it's going down. So never increasing, or we just put the empty set. When is it decreasing? Well, here we can use the interval notation. Okay, because it is going down, so we would just go from our lowest 0.4 to the highest 4. That's where it's decreasing. That's the domain in interval form. Now, max and min. Well, maximum would be right there at, what is that? 3 for the y value, 0.4. So max would be 0.43. Minimum, that lowest, would be 4 and 0.25. Do we have an x or y intercept? Nope. So we're good, and we move right on. Alright, now we've got another one that's also a discrete. Is it a function? Nope, because they're right there, right here. Because of those, doesn't pass the vertical line test, so not a function. But we can still talk about the key features of this. So, because it's discrete, we're looking at x's and y values instead of the interval for domain and range. Okay, so it's going to be some notation with all the x. So an x is a -11, a -9, even though there's two of them, a -6, at -3, at -2, at 2, 3, and I'm just going to keep writing up here, 3, 5, 6, 7, 8, 9, so 5, 6, 7, 8, 9, and 11 and 12. 11 and 12. Okay? So, there's our domain. Now our range would be the y value. So we've got 4, 3, 2, -1, -2, -3, -4. So -4, -3, -2, -1, 2, 3, and 4. It was a bit easier, wasn't it? Okay, do we have any x-intercepts? Nope, nothing on the x-axis. Any y? Nope, nothing on the y. So none here. Okay, do we have a maximum? Yeah, and on these we'd probably call them relative maximums, because I've got a couple, don't I? Here's a relative maximum. Here's a relative max. Here's a relative max. So those would be my maximums at -9, 4, at 5, 4, and at 12, 4. And I would probably call these relative maximums, because relative to the points around them, they are, but overall they're not maximum. Well, they all are maximums, but there's multiples. Okay, for the minimum, I probably just got those two right there. So at 5, -4, and at 8. Probably call them relative. 5, -4, and at 8, -4. Okay, now increasing and decreasing. This one's going to be tricky, isn't it? Because it's all over the place. So we increase here, we increase here, we increase here, I increase here, and increase here. So from -11 to -9 would be 1 increase, and I'm going to write them up here. From -6, so, and then you put a u there, to -2 we're increasing. Then from 2 clear over to this point right here, so 6, we're increasing another u. And another u from the last one, not negative, +8 to +12. So 1, 2, 3, 4 sections. Kind of crazy, huh? And that's where we are increasing. So now for decreasing, okay, it's kind of those other parts. So decrease here, decrease here, decrease here, here, and here. So from -9 to -6 we're decreasing. Now we jump from -2 to +2, and then we jump from 5 down to 8. So that would be our decreasing. So that was kind of a crazy one, wasn't it? Alright, here, this one. Much easier to deal with, right? X-intercept, pretty easy to jump on that one. Right here, and y-intercept right here. So y-intercept would be 0, -1. X-intercept would be about 0.3 maybe. maybe even 0.40. Those were pretty easy. Now I'm assuming that this just keeps going up, so there is no maximum, because it's just going to keep going up. A minimum looks like we do have -2, -1, 2, 3, 4, 5, 6, 7. So -2, -7. Oops. Crap. That actually was a point. -2, -7. Now, is it ever decreasing as we go left to right? Nope. Never. Or the empty set. Is it increasing? We look at the whole thing, so it's starting to increase here, right? The x value here, and then it's just going to keep going up until we go out to infinity. So it would be from -2 to infinity is when it's increasing. Which is also the domain, right? Because it's increasing the whole time, so the domain is the same as that increasing. The range, kind of similar, but it starts down here, which we said was -7, and it's just going to keep going up to positive infinity. So -7 to positive infinity. Alright. Okay, now this one, okay, got some issues here. For the most part it's continuous, but because of this little jog right here, we got to call it discrete. Is it a function? You want to say no, but it actually is. And the reason being, because that point right there is hollow, so when you do the vertical line test, it would actually still only touch right here. And then once you got past, it would be touching up here. So it actually is a function, oddly enough. Okay. So should we start with x-intercept? Sure. We've got an x-intercept here at 21. So 21, 0. X-intercept here at about 14.7, we'll say. So 2 x-intercepts. And a y-intercept here at 0, 10. Which also, that's our highest point, right? So that would be our maximum, 0, 10. Okay. Now over here, if we wanted to, we could call that a relative maximum. And we would call that 6, 7, 8, 8, 9. Sometimes we could do that. You don't necessarily have to, though, on this graph. Okay. So our minimum would be this lowest point here, which would be about right here, so 16, 17, 18 and a half. And we go down to about -2.7. Okay, so that's our minimum. So that -2.7, that's the start of our range, right? That's the lowest we go, -2.7, clear up to the highest, which is our max, which is 10. So notice how those ranges and domains connect with the other pieces. These features kind of, work together once you have one or the other. So our domain, we start at 0 right here, and we keep going till we get to 21. So there's our domain. Now the last, we have increasing and decreasing. So we decrease from 0 to 6, right? That's where we're going down. From 0 to 6. And then we jump, and up here at that relative maximum again, we go down to our relative minimum. So from this x value to this x value would be the decrease union from 8 to 18.5. That's where we're decreasing. So increasing is kind of in those other places, this little section and this little section. So from 6, where we left off here, to 8, where we take it back up, jump from 18.5 to the end, 21. There we have it. Alright, now in these ones it's not asking us to find all of the pieces, but just some of them. So our domain would be all the x values. Okay, we should probably write them 0, 1, 2, 3, 4, 5, 6. Our range, all the y or outputs, the f of x. So -3, 0, 2, 6, 12, and 20. X-intercept, where does y equals 0? That's our x-intercept, 2, 0. y-intercept, where it is x equals 0, 0, 2. And our minimum, what's our lowest value? Well, -3, so at 1, -3. So the table can be very easy to deal with, right? Oh, double crap. Said it represents a continuous function. So actually our domain should be from 0 to 6, and our range would be from -3 to 20. Because it's continuous, we're saying there's numbers in between here. Okay, so really that's what our domain and range should look like, which is actually easier to write, I think anyway. Okay, now this one's a discrete, so that's the difference. Okay, the discrete we'd call 1, 2, 3, 4, 5, whereas the continuous from 0 to 6. So our range, 3, 4, 5, 8, and 10. Okay. Do we have an x-intercept? Nope. Do we have a y-intercept? Nope. Do we have a minimum? Yeah. 5, 3 would be our minimum. Alright. Describe the key features for each situation. So, how would we deal with this? That's kind of what you're looking at. So the amount of daylight dependent on the time of year. Okay. So, we have a full year, 365 and a quarter days. So, our domain would be from that 0 day to 365.25, right? Our range would be from the smallest amount of daylight to the highest amount, which would be like what? The winter solstice to the summer solstice? So smallest to highest. I don't think we need to get too specific on it. Increasing. Well, thinking about that year from 0 to 360, when we get to the winter solstice, right, or summer solstice, it's going to be going down, decreasing till we get to the winter solstice. Then it's going to be increasing till we get back to the summer. Okay, so that would be the increasing and decreasing. Do we have an x-intercept? Yeah, that first day. Do we have a y-intercept? Do we ever have any day with no daylight? Unless you live up extreme north, for us it would be no. Maximum and minimum. Here's your maximum, here's your minimum. Okay. On these ones I'm not too concerned about us. I just want us kind of thinking through the concept, really. Okay, so the first term in the sequence is 36. Each consecutive term is exactly 1/2 the previous term. So 36 to 18 to 9 to 4.5 to 2.25 and so on. Okay, so this is actually probably easier to graph it. Starts at 36, the first term here is 36, then we're cutting it in half each time, so it's just going to keep going. So does it have a domain? Yeah, it's from 1 to infinity, because it's just going to keep going, cutting in half. We'll never get to 0. Range, highest we got was 36, the lowest is 0, because it'll never touch 0, but that's kind of our boundary that we could use. And so we'd actually put it in a parentheses, not a bracket, because that means it's a boundary, but we actually never touch it. Alright, kind of forgot where I was, got interrupted there. So let's see. Okay, so we got the domain and range. So it's always decreasing, right? So the decreasing would be the same as the domain. The increasing would be that empty set. It's never increasing. Maximum would be that 0.136. Okay, that would be our max. We don't have a minimum because it just keeps getting closer and closer and closer and closer and closer to 0, which means we never cross the x-axis or the y-axis in this situation. So there we go. Okay, number 14. Marcus bought a $900 couch on a 6-month interest-free payment plan. He makes 50 payments to the loan each week. Okay, so let's see. So he bought a $900 couch. So he started off owing $900, right? And he's going to keep paying it off, so 50. So it keeps going down for, every month, or every week. So 6 months would be 6 times 4, basically 24 weeks. So, it'd go to 24 when it should be paid off. Okay? So, the domain would be from 0 to 24 weeks, right? The range, we start at 900 and go down till we're at 0, so 0 to 900. So it'd always be decreasing again, so domain and decreasing would be the same. It would never be increasing, so that's the empty set. Okay. I just realized 15 and 13 are the same exact thing. Sweet. Don't do that one. The maximum would be that 0, 900, right? Which would also be our y-intercept. Okay. The lowest would be the 24, 0, when he's paid it all off. That would be our minimum, which would also be our x-intercept when it crosses the x-axis. Alright. We are almost out of time, aren't we? So, 16. An empty 15-gallon tank is being filled with gasoline at a rate of 2 gallons per minute. So, 15 gallons. We start out empty, and then minutes. So we got times here. Okay, so it's gonna eventually go up there, right? So here, our domain would be from 0 to however long it would take to get up to 15, which would be, so every minute we're going by 2. So it would be 1 minute, 2, 3, 4, 5, 6, 7. It would probably be actually a 7, wouldn't it? 7.5. So 7.5 is when we should hit that 15 mark. So 7.5. So our maximum point would be right there, right? Would be 7.5 and 15 when the tank is full. 17.5 minutes to get our tank, 15-gallon tank, to be full. Okay, our minimum would be where we started, which was 0, 0, which would also be the x and the y-intercept. The only time it's hitting the x and the y-axis. Okay, so our range would go from 0 to 15. That would be the gallons. Domain was the time. Range was the gallons. It's never decreasing, so decreasing would be that empty set or just never. And increasing would be the same as the domain. Alright, so these last ones, it wants us to sketch the graph and show key features of the graph. Okay, so I'm going to hurry and pause this so we have time, and then I'm going to sketch the graphs real quick. So we've got exponential 3. We start at 1 because it's 1 times 3 to the x. So our y-intercept is 1, and we're timesing by 3 each time. Here our y-intercept is 4. We're subtracting 2 each time, but x has to be greater than 0. So here's our exponential. Okay, growing pretty quick, keeps going. So max, there is none. Minimum, there is none, because it keeps getting close and close and closer to 0, but it's never going to quite hit 0. So our range would be 0 to, it's just going to keep going up to positive infinity. So we'd put positive infinity. Our range, or our domain, is all real numbers. It keeps going left, keeps going right. So from negative infinity to infinity, or you'd write all real numbers, which there's some fancy term that you can write there. It's never decreasing. Its increasing is the same as the domain. So negative infinity to infinity. Okay, there is no x-intercept because it never touches the x-axis. The y-intercept is at 0, 1. And there we go with that one. Now let's take a look at our linear. And by the way, that's pretty typical for our exponential equations when they're growing like that. This is pretty typical of how it's going to look. Okay, so let's look at our linear. So we're starting at our y-intercept is positive 4, but we are not going anywhere to the left. That's what this means, only to the right. So here's our graph. We start at 4, y-intercept, and we're going down 2 to the right 1, and we're just going to keep going. So our domain, we start here at 0, and we keep going until we get to infinity. Our range, start at 4, keep going until we get to negative infinity. It's never increasing. The decreasing is the same as domain. max, y-intercept, x-intercept, and we are done.